Welcome to our talk about deepfakes and audio forensics. We, in this case, are Patrick Aichroth from Fraunhofer IDMT and myself, Ruben Bouwmeester from Deutsche Welle. We only have a couple of minutes, so let's start. As you have a clear understanding of how social media works, I do not need to talk to you about the social networks and that they are places full of opportunities, but also full of trash. Nor do we need to talk about truth, all those people lying, confusing opinions with facts, all manipulation of content, taking content out of context, and manipulation of image and video, for whatever reason. Because for all of those news gathering and digital content verification tasks, we at Deutsche Welle, as I'm sure you have also, have generated workflows and tools to handle verification of digital content for journalists. At Deutsche Welle, we have developed our own collaborative verification platform called Truly Media. The tools that we have there are source analysis, detailed search queries made easy, image analysis, reverse image search, metadata, digging, smart zoom keyframes, maps, etc. Everything one needs for verification of digital content. What I want to talk to you about today is about this specific problem. Not this man, although I think that he definitely is and has a problem too, but the fact that due to technological advances, manipulation of media has become available to a larger audience and gets more and more difficult to detect. In Truly Media, we aim to also tackle video verification, but very often we have to treat video as a collection of images. We use visual verification for the video and can do forensic research on the images. Some research projects come up with better tools and possibly better interfaces to do video verification, and even other approaches are able to create soft biometric models to detect if we are looking at the real or at a synthetic Obama. What I feel we are missing, though, is some focus on another aspect of video that provides us with information. The audio tracks. As sometimes you need a bit of luck in life, my luck was that I got to know Patrick Aichroth from Fraunhofer IDMT at an ARD verification meeting in 2019. He showed me their audio forensics toolbox. He explained what audio forensic functionalities they had developed and how that could help us with audio and therefore also video verification. We talk about partial audio matching that could help us detect reuse of content or mashups, detect provenance, microphone analysis that could help us detect a change of microphone or an identification of the recording device, electrical network frequency analysis that could help us with cut, paste, deletion analysis or validation of a geolocation, and codec analysis that could help us with publication traces, change of codec, cut, paste, and deletion detection. Clearly, it was undeniable that this was the sign that I had been looking for. Also, Patrick was very interested in bringing his work into a new domain, namely journalism. So Patrick and me decided to work together on creating video verification solutions for journalists. We wrote a proposal and have received project funding from the Google Digital News Initiative for a period of 2 years with 3 partners, Fraunhofer IDMT, Deutsche Welle and ATC as the system integrator of Truly. Our aim being to integrate audio forensic tools in journalistic verification workflows. Our higher aim, however, is to search for ways to use audio forensic tools to detect synthetic media, also known as deepfakes. Going back to those audio forensic tools, this is what they provided as results. I personally cannot read this output. My estimation is that most journalists cannot read them either. These results raise a lot of questions. So let's go back to the previous slide and ask an audio forensics expert, Patrick Aichroth from Fraunhofer IDMT, to help us explain these visualizations. Hello, Patrick. Can you help us to understand what we see here?
Hi, Ruben. Happy to do that. Let's go through these points and start with electrical network frequency analysis. ENF analysis, as we call it, is based on the fact that sometimes in recordings you have traces of humming, which are get there by electromagnetic induction. And it's basically traces from our electrical network, and they can be, they show a frequency of either 50 or 60 hertz, depending on where you are in the world. But they also have some other interesting features, like the fluctuation around the 50 hertz or 60 hertz is random, and it's very homogeneous across larger geographical areas. And what you can do, because these fluctuations are so characteristic, is you can store them, and you can store them in a reference database and then compare them to what you have in the file, which is under analysis. And this can be used either to validate the recording time or the geolocation, at least on a very coarse-grained basis. But you can also use it to exploit the fact that if something is cutted or pasted, then you have inconsistencies with that electrical network frequency or the phase. And if that shows up, we know that there could be a manipulation and a cutting in a file. Another approach that we can use is coding analysis. Coding analysis is all about detecting traces of previous coding within audio material. So you can use machine learning to detect the amount and the types of codecs involved in the creation and the processing of files. But you can also use an analysis that we call inverse decoding, which is like a reverse engineering of the coding process, which provides very fine-grained information about how coding was applied. And this can be used to identify places where something was cutted or pasted or deleted within material. And then we have a third approach, which is called microphone analysis. This is based on the idea that you can use so-called source estimation to estimate what the original sound source behind the recording was. And using that, you can calculate the delta, the influence of the microphone and the recording device used to determine what the influence looks like. And what we get is a frequency response, which you can use to classify the device, or you can detect that there was a change of the device used during a recording, which would be very suspicious for a recording that is supposed to be one continuous recording using one device. And that's another hint you can use. And finally, we have two approaches called partial audio matching and phylogeny analysis. They are not detectors, meaning they are not tools which detect traces of manipulation or editing within one item, but rather they help you to analyze data sets. Partial audio matching can be used to detect reuse of content and to verify that something was reused, even if it's just a very short segment. And phylogeny analysis is an approach that can help understand in which order things were created, derived from each other. So it calculates so-called parent-child relations within a tree of connected items that were evolved from each other.
Many thanks, Patrick. So you can imagine that after many hours of discussion between Patrick and me, explaining my point of view, him explaining his point of view, we finally understood what we're actually looking at and what opportunities we have here. We are now working hard to translate these analyses into intelligible and usable interfaces for journalists. So let's make a workbench. Let's make a tool that we can work with. First of all, we will need a video under investigation with the metadata that belongs to it. And then we want to provide the user with all the tools needed to browse through this video. Go fast forward, go slow forward, frame by frame watching, and possibly some extra tools to enlarge or have an intelligent zoom in there. Let's take this video apart and look at segmentation and annotation. For that, we will need the timeline with an audio track that we can then annotate. Annotation means that we can make remarks for ourselves, but also remarks for colleagues that we work together with, so that we can keep track of what we have investigated already on the video. Our microphone analysis has now detected some microphone changes, and microphone changes do not necessarily mean a big problem. A microphone change is also there when we change scene or when we go from inside to outside. But when we have a microphone change within one sentence, we might have a manipulated sentence, so we'll have to look into that. The audio forensics metadata pops up and shows that the location that this video has been recorded at is a 60 Hz zone. So if we look at the world map and divide that in a 60 versus 50 Hz zone, then it could be correct that this video was recorded in the US. If we are suspicious that this video might be a mashup of some sort, then we would want to compare it with possibly what we think is the original of this speech. And for that, we use partial audio matching, which then gives a result that this video actually is a mashup and that elements of an original speech are being reused but in order and therefore taken out of context. Phylogeny and codec analysis didn't return any clues this time. Sometimes that happens, and it's mostly due to technical reasons. Either the audio snippet is too short or there's music over an audio which doesn't allow us to do our analysis. And there's all kinds of reasons for analysis not to return usable feedback. This is where we are right now. We hope to show you more next time we meet. Possibly even do some hands-on testing of our audio forensic tools. If you are interested in that, you can always get in contact with us. And you can follow the project via www.digger-project.com. Many thanks for your attention. We now have time for some questions.